concept of elementary particles. Okay, elementary particles. Now I suggest you, if you love the nuclear physics very much, मला खूपच जास्त आवडायला लागले nuclear physics, then I strongly recommend you to study the elementary particles, because this is the field wherein a huge research is going on nowadays. Means if you speak about the accelerator, if you speak about the counters, even if you speak about the basic properties of nucleus, all the things has been studied well. But now you people have a scope to do something in the elementary particle field, because really various interesting research, various interesting investigations are going on related with these elementary particles. Now, I suggest you, if you don't like the nuclear physics at all, म्हणजे खूप आवडत असेल तरी पण एलिमेंटरी पार्टिकल करा, पण तुम्हाला न्यूक्लियर फिजिक्स बिलकुलच आवडत नसेल, राईट, इफ यू सपोज दॅट दिस इज अ व्हेरी बोरिंग सब्जेक्ट, then also I suggest you to prepare for this topic first, because this is the easiest topic among all 4 units of nuclear and particle physics of your syllabus. So for both of the cases, extreme cases, you have to study this elementary particle unit. So what is mean by elementary particles? Elementary particles, the Google will give you back the definition that elementary particles are the smallest known building blocks of the universe. जैसे कि हमें पता है, we know that in a universe there are large amount of galaxies. That is, I can split universe into galaxies. If I look at some galaxy, I can even split up a galaxy into many stars. Suppose the sun is a star. Now, if I look into the sun, I observe that there are many planets in the sun. Among planets, if I focus on the Earth, I observe that Earth is not the smallest part, but we people, Anu, Renu, are present on the Earth, right? So, if I focus on the molecule or on the nucleus or atom, so I suppose that atom is the smallest part. But after Rutherford's discovery, it has been suggested that no, atom is not the smallest part, but there is something what we have called it as the nucleus, that is supposed to be the smallest one, right? At that time, it has been supposed that nucleus and electron, these are the smallest particles known to us. But further investigation said that this is not the nucleus that is the smallest one, but inside the nucleus there are proton and neutron that are supposed to be smallest one at that time, right? At that time म्हणजे खूप काही 100 वर्षापूर्वी नाही बरं का, अगदी 50-60 वर्षापूर्वी. So proton and neutron are supposed to be smallest. Electrons, proton, neutrons. Later on, it has been observed that proton and neutrons are not the smallest one, but these are the quarks, quark particles, that are the smallest known particle in the universe. Now, if I try to break down quark into some subdivisions, I cannot break a quark, what we call it as the elementary particle, into the smaller part. So what you can say, elementary particles are the smallest known particles. Smallest known particles. We cannot break the elementary particles to obtain something else. So these are the smallest one. Now, many books says that these are the building blocks of the universe. Right? Building blocks of the universe. जसं की आता आपण घर बांधताना नाही का, एक भिंत घेतो आणि एक विटावर विटा अशा रचतो नाही का. What you have observed, that the size, shape, width, height of all that particular block is same, right? So that's why we call that this is the building block of that particular wall. But When I say elementary particles, these are not exactly the building blocks of the universe, because suppose if I consider proton, बरं का, म्हणजे एलिमेंटरी पार्टिकलला खूप दिवसापर्यंत फंडामेंटल पार्टिकल्स पण म्हणलं जायचं. बट नाउ इट हॅज बीन सजेस्टेड दॅट in true sense, elementary particles are not the fundamental particles. म्हणजे कसं? Say, I have a proton, and I have been observed that proton is made up of some A, B, C elementary particles. We are going to see in detail, but for a moment, you suppose that proton has been formed by a combination of some A, B, and C elementary particles. Now, if the elementary particles are the fundamental particles, if these are the building blocks of the universe, then what should be true? Neutron should also be made up of ABC particles. Right? Neutron पण same त्याच particle ने बनायला पाहिजे होता. But it has been observed that neutron is formed by the combination of some XYZ particles. Not the ABC, but it has been formed by some XYZ elementary particles. If I focus on the meson, these particles are made up of some DEF particles, elementary particles, and in this way, you cannot say that these are the building blocks of the universe, but these are the smallest known particles present in the universe. For many years, the elemental particles, as I have said, these are known to be the fundamental particles, but now it is not so. Similarly, for many years, the elementary particles are said to be the strange particles. म्हणजे ज्याचा समानार्थी शब्द आपण म्हणू, एलिमेंटरी पार्टिकललाच खूप दिवसापर्यंत स्ट्रेंज पार्टिकल, एलिमेंटरी पार्टिकल को स्ट्रेंज पार्टिकल भी कहा जाता था, बिकॉज ऍट दैट टाइम देयर बिहेवियर वॉज व्हेरी स्ट्रेंज. कारण त्या काळात जास्त रिसर्च झालाच नव्हता. सो people thought that yes, these are the strange particles, something very different. But nowadays, up to the present day, various investigations has been done on these elementary particles, and these particles doesn't remain as strange as we are considering. So these are not the strange particles even nowadays. In this way, we can say what we have to remember: elementary particles are the smallest known particles. Then what these particles are doing? They are forming the matter, right? Elementary particle kute kute? These are the fundamental constituents of matter. These are the constituents of matter, right? By the collection of elementary particles, matter is going to be formed, right? Apart from these constituents of matter, the elementary particles are also the particles that could be exchanged during basic interactions. लक्षात ठेवा, elementary particles are not only the fundamental constituents of matter, म्हणजे जेवढे काही अणुरेणू आहेत आपले, that has been formed by elementary particle, no doubt. But apart from these constituents of matter, the elementary particles are also the particles that could be exchanged during the interaction process. For example, sun is shining outside, sun is producing some amount of energy, and we people here on the earth, we are getting that energy in the form of what? In the form of quanta of light, what we call it as the photon, right? So this is, we can say, it is an elementary particle. Likewise, this was just an example, but the basic interaction, when I say basic interaction, I should consider the gravitational interaction, I should consider the electromagnetic interaction, through which all chemical and biological processes will take place. I should consider the strong interaction and the weak interaction. These interactions, we are referring it as the basic interaction here, and the particles that get exchanged during this basic interaction, we call it as the elementary particles. So there are two main roles of elementary particles. They form the constituents of matter, and these are the particles that has been exchanged during the matter interaction, right? Now, let us move towards the very interesting concept or very interesting question asked by examiner. That was the classification of elementary particle. आता इथे वॉज म्हणायचीच वेळ आलेली आहे, कारण थेरॉटिकल एक्झाम तर आता तुमची होईल असं वाटत नाहीये. सो युअर एक्झाम विल बी ऑफकोर्स मल्टिपल चॉईस क्वेश्चन. This type of exam will be there. But if it was a theoretical exam, then the most probable question was the classification of elementary particles. Now there are various ways, criteria, with the help of which we can classify the elementary particles. कुठले कुठले criteria आहे? For example, elementary particles could be classified into different groups based on their spin. Elementary particles are classified into different groups based on their masses, based on their parities. So there are various concepts by which we can classify elementary particles into various groups. But now here in my explanation, I am using the classification that has been based on the spin of elementary particles. Spin of elementary particles. So depending on the spin of elementary particle, the elementary particles are classified as bosons and the fermions. Boson particles and the fermion particles. You know well that bosons are the particles that have integral multiple of spin, and fermions are the particles that are having half integral multiple of spin, intrinsic spin, right? Boson follow the Bose-Einstein statistics. Fermion follow the F Fermi-Dirac statistics, right? Now let us focus on the boson. The law of universe, law of nature says that nature काय सांगत आहे that the total number of bosons, in the universe, there is no control on the total number of bosons in the universe, but the total number of fermions in the universe should remain conserved. There is no any conservation law about the bosons. Bosons किती पण असू शकतात universe मध्ये, but there is a strict conservation law about the fermions, right? So this is the main difference between this boson and fermion, that there is no control about the number of bosons in the universe, right? Whereas the total number of fermions in the universe should remain conserved. Now let us focus on the boson family only. So this is the family that include the particles that will be exchanged during basic interaction. Boson मध्ये कुठल्या कुठल्या particles आहेत? Elementary particle. It includes the elementary particles that are exchanged during basic interaction, and it includes the family, what we called it as the meson family. Initially, it has been suggested that meson is a particle that will be exchanged during the strong interaction. Okay, meson is the particle that is going to be exchanged during strong interaction, but later on the thing has been changed. What has been studied we will see in detail, but for a moment remember जेवढे काही बेसिक इंटरॅक्शन आहेत, 4 प्रकारचे बेसिक इंटरॅक्शन आता आपण बघणारच आहेत. The particles that will be exchanged during this basic interaction are the boson particles. मग कुठले कुठले boson particles आहेत? The very well known is the photon particle, right? जसं की आताच मी तुम्हाला सांगितलं, sun will produce energy and we will get energy in the form of photon. So photon is a boson. Graviton, that is the particle that will be exchanged during gravitational interaction. नाही का, gravitational interaction म्हणजे जसं की sun आहे आणि earth आहे, in between sun and earth there will be a gravitational interaction. So there should be exchange of some particle, and that particle is named as the graviton, right? Photon is there, graviton is there. If I consider another kind of interaction, what we called it as the weak interaction, like a weak interaction. So the particle that will be exchanged during weak interaction, we called it as the vector boson particle, vector boson particle. And there is one more interaction, what we called it as the strong interaction. And the particle that will be exchanged during strong interaction is the gluon particle. Gluon, this is a quark particle that is supposed to be exchanged during the strong interaction process. So bosons include the particles that will be exchanged during basic interaction, right? आता I cannot control myself. Let me go directly to the slide which include the thing about the basic interaction in nature. Let me first cover this topic. Basic interactions in nature, right? How many basic interactions are there in nature? There are four basic interactions in nature, right? Four basic interactions. There is a strong interaction, there is a electromagnetic interaction, there is a weak interaction, and last but not least is the gravitational interaction. Right? We know gravitational interaction कुठे काम करते हैं? As I say, sun, the earth is revolving around the sun. Means all planets are revolving around the sun. So the interaction between sun and earth is of gravitational type. Even stars are revolving in the galaxy in some definite direction. So this interaction is also a gravitational interaction. The galaxy itself is a bound system by the virtue of this gravitational force, right? Electromagnetic interaction. This is the interaction that takes place during all chemical and biological processes, right? सगळ्या chemical आणि biological process मध्ये कुठली interaction होत असेल तर that is the electromagnetic interaction. Weak interaction. Although the name says it is a weak interaction, it is not the weakest interaction. How? We will see. But weak interaction is the interaction that mainly takes place during the decay of elementary particles. म्हणजे जे काही आता आपण बघणार आहोतच आणखी पूर्ण मेझॉन सांगितलं मी तुम्हाला किंवा आणखी हायपरॉन वगैरे ही फॅमिली आहे पूर्ण. So these elementary particles they get decay into different particles by virtue of this weak interaction. And we already studied the nuclear force. We already studied what happened inside the nucleus in our first unit. And this is the strong interaction that play a very important role in the strong nuclear reactions. So these are the strong interactions, right? So these are the four interactions in nature. Now, let me say you that at present, the research is going on. Just published a review also on this topic. That review says that all these interactions, these are not the different interaction, but these are the part of one single interaction. जो एक कुछ interaction जहाँ पे ना ऐसा रिसर्च ऐसा कह रहा है कि हमें ये दिखने के लिए चार इंटरेक्शन दिख रही है, but this interaction, all these interactions are, you can say these are the member of some basic interaction. There should be a basic force in the universe. ऐसा कहा जाता है जिसे हम कह रहे हैं, जिसे आगे चल के हमें देखना है कि जिसे कहते हैं ग्रैंड यूनिफिकेशन थ्योरी. ग्रैंड यूनिफिकेशन थ्योरी क्या कहती है? फोर्स की. ये थ्योरी कहती है कि दुनिया में चार प्रकार के फोर्स नहीं है, दुनिया में एक ही प्रकार का फोर्स है. एंड ये जो हम चार प्रकार देख रहे हैं वो एक ही प्रकार के फोर्स के अलग अलग एंगल्स है, राइट? This is the grand unification theory. If you are interested, you can go in detail in the grand unification theory. But really, this is very interesting topic for me. So, in this way, now at present moment, there are four basic interactions. Let us do the comparison of all these interactions. Let me go from the weakest interaction to the strongest interaction. The gravitational interaction is the weakest interaction among all these four interactions, gravitational interactions. And we know the gravitational interaction will take place by the virtue of its mass. ठीक है। किसी भी बॉडी को मास है तो दो बॉडीज में ग्रेविटेशनल इंटरेक्शन भी होगा। जैसे आप सन एंड अर्थ एंड ऑल एस्ट्रोनॉमिकल बॉडीज में जो कुछ भी इंटरेक्शन है दैट टेक्स प्लेस थ्रू द ग्रेविटी। इसका मतलब ऐसा है क्या कि प्रोटॉन न्यूट्रॉन में ग्रेविटेशनल इंटरेक्शन नहीं है? बिल्कुल है, प्रोटॉन और न्यूट्रॉन में भी ग्रेविटेशनल इंटरेक्शन है, बट द ओनली थिंग इज दैट ये दोनों बॉडीज का मास जो है बहुत ही कम है, उसकी वजह से उसका ग्रेविटेशनल इंटरेक्शन जो है बहुत ही निग्लिजिबल है। व्हेनेवर देयर इज मास देयर इज अ ग्रेविटेशनल इंटरेक्शन, राइट। रेंज क्या है ग्रेविटेशनल इंटरेक्शन की? इनफाइनाइट रेंज है, राइट। ग्रेविटी इज द फोर्स दैट बाइंड द ह्यूज यूनिवर्स, राइट। इसका मतलब क्या है, इसकी जो रेंज है वो इनफाइनाइट रेंज है ग्रेविटेशनल इंटरेक्शन की। सो as I have said that the particles that get exchanged during the gravitational interaction is the graviton particle। graviton particle है ना, graviton particle जिस पर स्टीफन हॉकिंस ने बहुत ज्यादा स्टडी की है। So the graviton is a boson whose mass is 0. This is the massless particle. Say all bosons are massless particle except this vector boson, बरं का? फोटॉन पण massless आहे, ग्लुऑन पण massless आहे, graviton पण massless आहे, but what they have is the spin that which is equals to integral multiple of h cross. So in case of graviton the spin is 2, right? Graviton is a massless particle with spin 2, right? So this is about the gravitational interaction. Strength I will explain later on. Weak interaction. The interaction, as I have said, this is the interaction by virtue of which the elementary particles get decayed. There will be a leptonic decay, there will be a non-leptonic decay, right? हे जे काही decay होतो, larger particle it get converted to smaller particles. This decay will take place with the help of this weak interaction, right? Weak interaction. And as this interaction is taking place only for the elementary particles, this weak interaction is a short range force. It is a short range force. Now here the range is given to be 10 to the power minus 18 meter, right? So it's little bit beyond the nuclear size. Nuclear size आपल्याला माहित आहे 10 to the power minus 15 आहे. So weak force it could act just few distance than the nuclear size, नाही का? न्यूक्लियर साइजच्या थोडंसं पलीकडेपर्यंत हा वीक फोर्स काम करू शकतो. Now what is the particle that get exchanged during the weak interaction? This is the vector boson particle. त्याचं नाव काय दिलेलं आहे? वेक्टर बोझॉन पार्टिकल. त्यालाच काय म्हणतात? वीक बोझॉन पण म्हणतात, बरं का? हे W म्हणजे W स्टँड फॉर वीक. So vector bosons are also known as the weak boson particle. This is the only interaction boson that is having some mass. फक्त यालाच मास आहे, बरं का? याच बोझॉनला मास आहे, having mass about 80 or 90 giga electron volt. Weak boson is thus not a massless particle and is having a spin of 1. ठीक आहे, वीक बोझॉन किंवा वेक्टर बोझॉनचा स्पिन किती आहे? 1 आहे. Next to this, a much stronger interaction compared to gravitational interaction or weak interaction is the इलेक्ट्रोमॅग्नेटिक इंटरॅक्शन. ह्या दोघांपेक्षा पण थोडीशी जास्त प्रमाणात असलेली कुठली इंटरॅक्शन आहे? दॅट इज द इलेक्ट्रोमॅग्नेटिक इंटरॅक्शन. या दोन्हीपेक्षा या इंटरॅक्शनची स्ट्रेंथ थोडी जास्त आहे. सो वी नो इलेक्ट्रोमॅग्नेटिक फोर्स एक्झिस्ट whenever there are charges, right? It could be attractive type of interaction or repulsive type of interaction. सेम चार्जेस असतील तर रिपल्सिव्ह असेल, डिफरेंट चार्जेस असतील तर अट्रॅक्टिव्ह इंटरॅक्शन असेल. अनलाइक टू द ग्रॅव्हिटेशनल इंटरॅक्शन. ग्रॅव्हिटेशनल इंटरॅक्शन रिपल्सिव्ह असू शकते का? कधीच नाही. ग्रॅव्हिटेशनल इंटरॅक्शन विल ऑलवेज बी an attractive interaction, right? So if I focus on the electromagnetic interaction, it could be attractive interaction or repulsive interaction. It arises by virtue of the charge of particle. What is the range of electromagnetic interaction? It is of infinite range. इनफाइनाइट रेंज तक इलेक्ट्रोमैग्नेटिक फोर्स जो है काम कर सकता है, राइट. एंड व्हाट इज द पार्टिकल दैट विल बी एक्सचेंज ड्यूरिंग द इलेक्ट्रोमैग्नेटिक इंटरेक्शन? इट इज द photon. It is the photon particle that get exchanged during the electromagnetic interaction, right? Photon. Photon का mass क्या है? Photon का mass 0 है. This is a massless particle and is having a spin of 1. It is a particle with spin 1. ध्यान से याद रखिए ये सब, spin, mass वगैरह. And let us move towards the strongest force in the universe. That is the strong nuclear interaction. Nuclear interaction है तो of course short range force है, हाँ, as I have said already. Strong nuclear interaction is a short range interaction. Range उसकी कहाँ तक है? Only up to the nuclear size, that is few femtometer, right? Few femtometers इतनी उसकी size है. Strong interaction is said to be charge independent. बरं का? म्हणजे पुस्तकात तुम्ही तयाल जर बघायला लागलात किंवा घोषाल बघायला लागलात तर they will say that strong interaction is charge independent interaction, but the recent investigation says that it is not the truly charge independent. म्हणजे प्रोटॉन मधला जो चार्ज आहे, जी इंटरॅक्शन आहे, that is not exactly like the neutron proton interaction or neutron interaction. It is not exactly same to same, but it is nowadays said that strong interaction is not so called charge independent interaction, right? पण तुम्ही जुने पुस्तक बघितलात तर तुम्हाला हेच वाचायला भेटेल की this is the charge independent interaction, strongest interaction in the universe, which act only up to the nuclear size. So it is a short range interaction. The particle that will be exchanged is the gluon particle. This gluon is actually a quark particle. Remember, gluon is a quark particle with mass 0 and spin 1, right? So, as I am saying, this strong interaction is the strongest interaction in the universe. Say its strength is 1. Its strength is 1. So, if I consider the strength of strong interaction to be 1, then the electromagnetic interaction is 137th times smaller than the strong interaction. यापेक्षा इलेक्ट्रोमॅग्नेटिक इंटरॅक्शनची स्ट्रेंथ कितीने कमी आहे? 137th times smaller than the strong interaction. Compared to strong interaction, weak interaction ची स्ट्रेंथ किती आहे? 10 to the power -6. इतका हा वीक इंटरॅक्शन वीक असेल compared to the strong interaction, नाही का? 10 to the power -6 times the strong interaction. Coming to the last interaction, but very important interaction, gravitational interaction. It is supposed to be 10 to the power -39 times the strength of strong interaction. म्हणजे खूपच कमी आहे, नाही का? हा ग्रॅव्हिटेशनल फोर्स खूप कमी आहे. You can even calculate the ratio of electromagnetic interaction between proton and neutron and gravitational interaction between proton and neutron. You know the formula for electromagnetic interaction, 1/4πε0 q1 q2 upon r square. Gravitational interactions आपण फॉर्म्युला माहित आहे तुम्हाला, नाही का? 1/g का किंवा g proportional मध्ये असेल. So some constant into m1 m2 divided by r square. So you can calculate the electromagnetic interaction, you can calculate the gravitational interaction, and you can obtain the ratio of electromagnetic interaction to gravitational interaction. That could be a question for your university exam also, right? So in this way, you can study the things, or you can compare the basic interactions or the fundamental forces in the universe, right? Fundamental forces in the universe. And now, ऐकत आहे ना सगळे? ऍटलीस्ट एक दोघं तरी ऐकत आहे का?
Yes, ma'am.
हो मॅम.
Okay, fine. So, as we have studied, all particles that could be exchanged during basic interaction they comes under the heading of boson. All these particles are massless particle except this vector boson. Vector boson म्हणजे वीक इंटरॅक्शन ही वीक का आहे, तर हा जो कॅरियर आहे त्याला काहीतरी मास है, तो जर कैरियर, ये जो कैरियर है अगर ये मासलेस रहता तो ये वीक इंटरैक्शन भी शायद सबसे ज्यादा स्ट्रॉन्ग रहती। समझ में आ रहा है? ये सबकी इंटरैक्शन पार्टिकल ये बहुत ही मासलेस पार्टिकल है, इनको कुछ ज्यादा एनर्जी नहीं लगने वाली इधर से उधर जाने के लिए। बट vector boson, that is the carrier of weak interaction, it is a mass, it is a particle having some mass, and that's why weak interaction is slightly weak compared to the strong interaction, है ना? ऐसा आप ध्यान में रख सकते हैं। So for all these particles the spin is 1 except the graviton, it is having spin 2. So this is one class of boson. Another class of boson contain particle, what is called it as the meson. Meson particles are having some mass. बरं का, या पार्टिकलला स्वतःचा काही मास आहे. So meson, they are grouped under various categories like pi mesons, k mesons and eta meson. Eta meson. Under the pi meson or pion, there are 3 members: pi plus, pi minus, pi 0. 3 members are there in this pion family. 4 members are there in the kaon family or k meson family. K meson family, and there is only one member, that is eta 0 meson under the eta meson family. There is only one meson in this particular family, right? Under the family of kaons, there are 4 particles. As I have said, there are 4 particles. K plus, K minus, K0 and K0 bar. These are the 4 particles that comes under the heading of this kaon family, right? So this is the family of boson. This is the class of boson. Remember, all these interaction particles are also known as the gauge particles. Gauge particles. कारण ह्या सगळ्या इंटरॅक्शनला, म्हणजे मी आताच तुम्हाला सांगितलं ना की all interaction are supposed to be a part of one interaction. त्याला की मग mathematically gauge interaction पण बोललं जातं. So all these particles are named as gauge particles, right? That you have to remember. Now, coming to the point of fermions, which should remain conserved in the universe. They are having half integral multiple spin of H cross. These fermions are grouped into 2 families based on the mass. बरं का? Leptons जे आहेत, leptons that are lighter particles, lighter कुणापेक्षा? मेझॉन पेक्षा. बरं का? हे फर्मिओन 2 फॅमिली मध्ये डिवाइड झाला डिपेंडिंग ऑन मास, बट रेफरन्स मास कोणता आहे? मेझॉनचा मास आहे. So leptons are the lighter particles. Baryons, on the other hand, are the heavier particles. Heavier particles. Which particles come under the head of lepton? Yes, this is our electron, tau particle, neutrino, muon, all these lighter particles and their antiparticles and their neutrino. कारण electron neutrino असतो, muon neutrino असतो, tau neutrino असतो, right? So all these particles comes under the head of leptons. These are the lighter particle. It contain lighter particle and associated antiparticle. या प्रत्येक पार्टिकल साठी एक अँटीपार्टिकल आहे बरं का. इवन द रिसर्च नाउ सेज दॅट, म्हणजे असंच इंटरेस्टिंग काहीतरी, इट सेज दॅट देअर शुड बी सम अँटी युनिव्हर्स. असं असं लोक म्हणतात, ज्याला म्हणजे बरेच जण हसतातही, अरे असं कुठं असू शकतं का, अँटी युनिव्हर्स असू शकते का. But who says that no, there is no anti-universe? बिलकुल असू पण शकते. म्हणजे आता खरं बरं का, असं मला वाटतं की एलियन पण असतील असं मला वाटतं, म्हणजे माझं पर्सनल मत आहे. कारण माणूस जितका काही विचार करतो त्याची वैचारिक लेवल कुठपर्यंत जाते तिथपर्यंतच जग नक्कीच अस्तित्वात आहे अशी माझी धारणा आहे. चला, तर leptons include particles and their antiparticle and the neutrinos associated with that particle. Coming to the point of baryon, these are the, yes, any question? Yes, the baryons, these are the heavier particles. It includes the nucleons and their antiparticle. न्यूक्लियॉन अँड देअर अँटी पार्टिकल म्हणजे काय, प्रोटॉन आहे, अँटी प्रोटॉन आहे, न्यूट्रॉन आहे, अँटी न्यूट्रॉन आहे. इट कम अंडर द हेड ऑफ बॅरियॉन, बट अलॉंग विथ दिस न्यूक्लियॉन it include a very special particles. These are the very, you can say, rich particles. म्हणजे रिच फॅमिली मधून येतात ते हायपरॉन. रिच म्हणजे कसे, ते असे बसतच नाही, स्टेबल बसतच नाही, बिलकुल अनस्टेबल. म्हणजे त्यांचं एकतर मास खूप जास्त आहे, दे विल टेक पार्ट इन टू द स्ट्रॉंग इंटरॅक्शन, इवन they are very unstable particles. So it come under the head of hyperons. How many hyperons are there, or how many groups are there? There are 4 groups: lambda hyperon, sigma hyperon, psi hyperon. Okay, psi, KSI, psi hyperon, and only one member. This is the richest member because it is having charge minus minus and having spin 3/2. जसं इकडे ग्रॅव्हिटॉन हा एक्सेप्शनल आहे, ह्याचा स्पिन 2 आहे, बाकी सगळ्यांचा 1 आहे. तसा हा ओमेगा पण एक्सेप्शनल आहे बरं का, हा भारीच आहे एकदम. भारी इन द सेन्स याचा मास पण खूप जास्त आहे सगळ्यापेक्षा, याचा चार्जही खूप सगळ्यांपेक्षा जास्त आहे, याचा स्पिनही सगळ्यांपेक्षा जास्त आहे, आणि ह्या फॅमिली मधला 1 अँड द ओनली मेंबर आहे ओमेगा, राईट. तसं साय फॅमिलीचं नाहीये. देर आर 2 मेंबर्स इन साय फॅमिली. हे मेंबर पण थोडे स्ट्रेंज आहे, आपल्याला पॉझिटिव्ह 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 बघून सवय झाली आहे. हा सुखी मेंबर आहे या काळात. दिस इज द साय नेगेटिव्ह मेंबर अँड साय झिरो मेंबर, राईट. दीज आर द 2 मेंबर्स. म्हणजे आज नाही का नेगेटिव्ह शब्द ऐकलं की छान वाटतं, वा वा निगेटिव्ह, तसं हा नेगेटिव्ह आहे आणि हा साय झिरो आहे. In sigma family, as like in pion family, there are 3 members. In sigma family also, there are 3 members: sigma plus, sigma minus, sigma zero. In lambda family, हा जितका रिच आहे ओमेगा, तितका हा लॅम्बडा पुअर आहे मासच्या बाबतीत. This lambda, this is again a family that only have that is having only 1 member, right? That is lambda zero hyperon. लॅम्बडा झिरो हायपरॉन. आणि हे जे सगळे बॅरिओन आहेत त्यांचं काहीतरी खूप मास आहे, जास्त मास आहे. प्लस हे मेझॉन जे आहे नाही का, मेझॉन्स अँड बॅरिओन्स, these 2 particles or these 2 groups are called as the hydrons. Okay, hydrons. आणि yes, this baryon along with meson, they are known as the hadrons. Hadrons. आता what is the speciality of hadrons, right? Speciality of hadron is that they are strongly interacting particle. बसतच नाहीत निवांत, लगेच क्विक इंटरॅक्शन. So this particle, like meson particle, baryon particle, we are calling it as the hadron particle. राईट. मास कसं आहे हायड्रॉन पार्टिकलचं, व्हेरी मासिव. म्हणजे असे मासलेस नाहीयेत किंवा लेप्टॉन सारखे कमी मासचे नाहीयेत, बट दे आर हॅव्हिंग सम मास. इट्स कन्सिडरेबल मास. वी कॉल्ड इट ॲज द हायड्रॉन. These are strongly interacting particles. These are massive particles. Moreover, one very good thing that you have to remember about hadron is that these are not the truly elementary particle. माझ्या मते बरं का, असं कुठं पुस्तकात नाही लिहिलं, बट hadrons हे खरोखरच एलिमेंटरी पार्टिकल नाही आहेत. We can even break the hadrons. I can even break the meson baryon into sub elementary particles. What we called it as the quarks. क्वार्कची स्टडी नंतर झाली, क्वार्क नंतर शोधला गेला. अँड इट हॅज बीन लॅटर ऑन सेड दॅट हे जे काही आपण बॅरिओनला इलिमेंटरी पार्टिकल म्हणत आहे किंवा मेझॉनला इलिमेंटरी पार्टिकल म्हणत आहे, राईट, वी आर सेइंग मेझॉन इज इलिमेंटरी पार्टिकल, बॅरिओन इज इलिमेंटरी पार्टिकल, बट इट इज नॉट सो. आफ्टर द इन्व्हेस्टिगेशन ऑफ क्वार्क, it is said that these hadrons are the particles that are made up of combination of 2 or more quarks. म्हणजे बेसिक इलिमेंटरी पार्टिकल हे खूप कमी आहेत. इट इन्क्लूड क्वार्क, त्याच्यापासून हे सगळे तयार झालेले आहेत. इट इन्क्लूड लेप्टॉन्स, लेप्टॉन क्वार्क पासून नाही बनले, ते स्वतःचेच इलिमेंटरी पार्टिकल आहे स्वतःच. आणि बेसिक इंटरॅक्शन पार्टिकल. These are the only 3 groups that comes under the head of elementary particle. आणि म्हणूनच जर तुम्ही इंटरनेटवर क्लासिफिकेशन ऑफ एलिमेंटरी पार्टिकल स्टडी करायला गेलात तर यू विल नोटिस दॅट देयर आर 3 groups of elementary particles. Here is the boson family. It includes all particles that could be exchanged during basic interaction. It includes quark particle पण आहेत elementary particle मध्ये, and it includes electron, muon and tau. As I have said, these are the leptons. So only leptons, quarks and basic interaction particles, these are only the elementary particle at the present moment. बरं का? म्हणजे ही जी फिगर आहे ही फिगर ज्यावेळी अस्तित्वात आली त्यावेळी कदाचित किंवा as I have said, this classification itself is based on the spin. But you have to remember that basically there are how many elementary particles? 1, 2, 3, 4, 6, 10, 12. There are 14 elementary particles in the universe that you have to remember always. 2-3 वर्षाखालपर्यंत मला कळतच नव्हतं बरं का की ही फिगर म्हणजे मला ही फिगर खूप आवडते एलिमेंटरी पार्टिकलच्या क्लासिफिकेशनची, राईट, विच इज सजेस्टेड बाय DC Kayal. But when I asked Google, it always show me this figure. So I was very confused before 3-4 years. I was very confused how this classification is there. But now the thing has been cleared. This is the true classification of elementary particles. Okay. So let me stop here for today. If you have any query, you can ask me right now. सतरा स्टुडंट फक्त, बाकीचे कुठे गेले? तुमची इच्छा.